Okay, x values with the graph. What am I going to put for range? Y values and height. The graph. Okay, the height of the graph. You got to get really familiar with that. What is the y-intercept? Tell me what it is. Don't tell me how to find it, but tell me what is the y-intercept?
The point that the line crosses on the y-axis.
Okay, it's where the curve or the graph crosses the y-axis. And of course, we are not going to have calculators to be able to blow up, so you've got to know how to do all this stuff algebraically. That's right. Yes. What about the what are zeros or roots? When x equals 0, what'd you say?
I just said the x, where it crosses the x-axis.
Well, if you got the y-intercept, then the zeros or the roots or the solutions. This one has all kinds of terms. These are the x-intercepts. And it's where the curve crosses the x-axis. Okay, watch the video to write them down, then knock yourself out, mark 140 on the video. But what would the domain be for example 1? Uh-oh. Does everybody agree? Oh, it doesn't include what when x is what?
-4.
-4. Okay, so we got to recoup. All right, so let's fix this. How would I write using interval notation from here to here? Bracket -8 to union. With the parentheses? Because it's got to go here all the way to what? -4 to infinity. You guys agree with that? How about range? What would the range be for that? Negative, let me see, 4, 6, 8, that'd be -10, because these are in twos. -10 to what? Positive infinity. That gets that thing, parentheses. What about the left side? What's a -10 get? Bracket. Is everybody cool with this? Especially those of you who haven't been here. Are y'all good with this?
Yes.
Yeah? Okay. With the signs. Oh, the domain would be, so x would fall there, there, and x is greater than. You would never see it written as an inequality, okay? But that's how you would do it if you did. What about the x-intercepts? What about the x-intercepts on this? -6. How am I going to write it though? I would write it with as a set using the fancy brackets. So -6. What's the next one? Can we agree that it's about -2? Are we cool? -2, 3. Y'all cool with that? Yeah? What about the y-intercepts, if there are more than one? -6, -7. Is that it? Can I write a set of one value? Heck yeah, definitely you can. Do we have any questions? If I give you a picture, you're good to go, right? On the x and the y-intercepts. Now, of course, we ain't gonna do that. We ain't gonna do this either. We ain't gonna do that. We're not gonna do that. Yes, we are. I told you a lie. Told you a big old lie. We're gonna put something in here. How to find intercepts algebraically. Algebraically, okay? How to find the x-intercepts algebraically. When I find x-intercepts, I want to end up with x equals something. Okay? That's what I want to end up with. In order for me to end up with x equals something, I plug 0 into the equation and solve for, plug 0 into y in the equation and solve for x. Plug 0 into y in the equation and solve for x. That's how you find the x-intercepts algebraically. Did you guys do this in Algebra 2? You remember? You do? If I were to, I would show you how to do this, but I would never focus on this if I were teaching Algebra 2, because, you know, you're going to blow that calculator up. Y-intercepts, I want to end up with not x equals something, but you tell me, y equals something. So we're going to plug 0 into what? X. In the equation. And solve for y. Problems? And see how we're going to do this. Let's check this one out. We're going to find the x and y intercepts of the following if they exist. If they exist, because sometimes they don't. Okay? You with me? Look alive. Write this down. Don't sit there with your thumb up your hee-haw. That would be just weird. It happens. Sometimes I have to get your attention. That's the way I do it. You're welcome. You're welcome. All right, so let's find f of x is equal to x cubed minus x. First of all, f of x, we interchange it with what? Y. So if you feel like you need to rewrite it, you rewrite it. Y equals x cubed minus x. X-intercept. The x-intercept, I want to end up with what equals something. X equals something. So I have to plug 0 where? I have to plug 0 in for y. So here we go. 0 is equal to x cubed minus x. How in the world do we solve that? Y'all remember? No, there's no formula. But it is a cubic equation, so it's going to look like the what? Some form of John Travolta. It's going to look like some version of John Travolta. You guys know what to do? Anybody? If I do, it's going to cause me to kind of start chasing my tail. Anytime you have any type of polynomial equation and you've got to solve it, it has to be set equal to what number? It has to be set equal to 0. It is. We're safe. But what's the next thing we would have to do? If I had an equation like this, okay, you don't have to write this down. If I had x squared plus 2x plus 1 equals 0, how would you solve that? Quadratic equation. Anybody remember? What's this mean? You would factor it and then set each factor equal to 0 and solve, wouldn't you? Okay, this is what you need to write down. Set equation equal to 0, factor, set each factor equal to 0, and solve. This is the way you solve these polynomial equations. Make sure that your equation is equal to 0, then we're going to factor it, then we're going to set each factor equal to 0 and solve. And you did all this stuff. You did all this last year, okay? Now, this is not a quadratic. It is a cubic equation, as you said. But I still have to factor it. What do you factor? What do you factor out of x cubed minus x? The GCF. Thank you. The first thing you always try to factor out always is your GCF. What is the GCF? Yes, it is the greatest common factor, but for x cubed minus x, what's the GCF? X. Good. Okay? X times what is x cubed? X times what is x cubed? X squared. X times what is negative x? Good. Whoever said that? Ooh, this is a double whammy. It's factored. Is it factored completely? No. Why? Because it's a difference of who? It's now we got a difference in squares. Holy crap! She has thrown 14 problems into one, hasn't she? Yes, she has. Because why not? So we got to continue factoring this difference of squares. Here we go. How do you break down that difference of squares, y'all? That's the easy part. Come on now. X minus and there we go. Somebody's got to get a skull. You guys remember doing that? You got to be able to factor. Now, is it factored completely? It is now. Now, what do I do? You know what we should do over here? Is that right? Is it ELY? Completely? Doesn't look right. Is it right?
Yeah.
Okay. I don't want it to be wrong. Factor completely. Now, take each factor, set them equal to 0. Set each factor equal to 0. And here's where everybody usually freaks out. X equals 0, oh my God! And that's okay. That's the solution. That is an x-intercept. Solve them. Add 1. Subtract 1. Y'all with me? So how many x-intercepts does this curve have? It has 3. It has 0, 1, and -1. I do not care if they're not in order. I just want you to have the right answers. Another way you could write them, you could do it that way. I don't care. You could write x-intercepts equal, blah, blah, blah. Either way is fine and acceptable. Okay? Is everybody good? Are we riding that bicycle? Are we a little bit more steady now? Super duper. That's awesome, y'all. Thank you for your response. Tells me so much. How about what's next? What do we have to do? Now we got to find the y-intercept. All right? Y-intercept. Same equation. Y equals x cubed minus x. What am I going to do? Plug 0 in for x. Okay. This will be fun. What's 0 cubed? Heck yeah. Minus 0 is? For real, are we done? Yep, for real, we're done. That's our y-intercept. Typically, one of the intercepts will be easier to find than the other, just because. And that's the way we like it, okay? Have we done anything new? No, we really haven't. We've done stuff, this is just a review from Algebra 2, folks, okay? Without a calculator. To y equals the quantity, the square root of the quantity 4x plus 1. And we've got to find the x-intercept. What do I do in order to do that? Joe, you made eye contact. What do I do? Never look at me. Never look at me if you don't want to be called on. Look, and y'all are like, or don't do this. I look at you and then you go. It's hateful. Go ahead, Joe.
0 is greater, less than or equal to 4x.
All right. How do I find the x-intercept? What do I do? Plug 0 in for what? For y. All right, and watch what I have to do. Plug 0 in for y, and just rewrite it, okay? All I'm doing is putting 0 in for y. Now, how in the world am I going to solve that? I don't like that radical, do y'all? Do what? How come? To get rid of the radical. If I want to get rid of the radical, then square the right side. But if I square the right side, then I have to do what? I have to square the left. Okay, watch. What's 0 squared? 0. What is the quantity, the square root of the quantity 4x plus 1, the quantity squared?
4x plus 1.
Well, it cancels it out, right? So I've got 4x plus 1. Can I solve that for x? Yeah, that's easy. Subtract 1. X is equal to negative 1/4. Is that right? Must be, right? Okay, we solved it correctly. Let's go over here to the y-intercept. How many of you had negative 1/4? Did anybody? Oh, several of you. Good. Okay. Now what? How do I find the y-intercept? 0 in for x. So we got y is equal to the square root of 4 times 0 plus 1, right? Y is equal to the square root of 0 plus 1. Y is equal to the square root of 1. What's the square root of 1? Got to be careful here. And this is why I say to go back and draw this picture. What is the square root of 1? Is it just plain old 1? It is just plain old 1. Do you know that sometimes when you force a square root, if I would have had this, y'all, crap. How would I have solved that equation for y? What would I have to do? I'd have to what? Take the square root of both sides. Check this out. I am forcing a square root, correct? What I do to one side, I have to do the other. We get y. What's the square root of 4? In this case, when you force the square root, it's actually plus or minus 2. For this one, are we forcing the square root, or is the square root symbol already there? It's already there, so I don't have to take into account the plus or minus piece of it. Here, I'm forcing the square root. Here, I'm not. It's already there. The square root is already there. So I don't have to put plus or minus 1. And I want you to think, if you did put plus or minus 1, y is equal to plus or minus 1. Does that curve even come down here to negative 1? Yes or no? Why? Think about it. If it were negative 1, this is what it would look like. Folks, can a square root be equal to a negative number? Ever? No. Because then we're not dealing with the set of real numbers, we're dealing with the set of what kind of numbers? Imaginary, okay? So we can never have that right there. We can never have a square root equal to -1. That's kind of a funky problem, but it's good to show. I would rather show you that type of problem in class rather than say, hey, here's your homework. Look, give you something like that, and then you're going, what is she doing? Why didn't she show us one like that in class? So typically, I'm going to show you difficult problems in class, so when you get home, hopefully, they're not so difficult, okay? Questions? X and Y intercept. Could you find X and Y intercepts algebraically by yourself? Yeah, plugging in zeros, right? And then crunching equations. It's just algebra. Let's change gears. Let's talk about symmetry. Symmetry's fun. I believe you have to understand, you will not understand how to find symmetry if you don't understand what it's about, why it's about, how it's about, okay? Make you 3 nice columns. And you gotta hang in here with me. Put your seatbelt on because we're getting ready to roll. What the picture is gonna look like, okay? If a function is symmetric to the origin, it is said to be called an odd function. It's going to look like this. Means that if I were to put, y'all remember when you were little and you were learning time, how to tell time? You would make the face of the clock with the movable hands. Do you remember that? And you had to put that little brass thing in the middle of the clock. Y'all remember that when you were little? Y'all had to learn how to tell time, right? Did y'all make it? You had to make the paper plate clocks, yes. And you had to stick that thing in the middle so you could move those hands around. If you can imagine one of those brass fasteners right here in the middle, I could turn that function around the center of my coordinate plane, okay? Now, notice the ordered pairs. What changed from quadrant 1 to quadrant 3? What's negative? They're both changed into their opposites, didn't they? Okay? So, X became negative X. And, this is important, Y became negative Y. They became their opposites. Notice that they're in kind of opposite corners of the coordinate plane. So would it also stand that if the function was in the second quadrant, where would the rest of it be if it were symmetric to the origin? It'd be in the fourth because they need to be in opposite corners. Does that make sense? Okay, they have to be in the opposites. Let's look at the y-axis. The y-axis. Here's how the y-axis is an even. If the function is symmetric to the y-axis, it is an even function. Would you guys agree that most parabolas, if it's not been shifted right or left, most parabolas are going to be symmetric with respect to the y-axis? If I were able to fold the parabola up, then wouldn't every piece of the curve match on a piece of paper? What happened to the ordered pairs? If this is x, y, then what's this going to be? Think. Negative x, because you went left. Will the y change? No. So what's the only thing that changed here? The x. X became negative x. Oh. And then we got to y, the x-axis. The x-axis is neither even nor odd, so we'll just put neither. It's a neither case. It's not even, it's not odd. The picture is going to look like this. What do you think if a function is symmetric with respect to the x-axis, what could it look like? What kind? A sideways parabola, absolutely. A sideways parabola. So if its xy is up here, what's the ordered pair for the bottom piece? X negative y. Now you know what I'm getting ready to come over here and write. What changed? Y became negative y. Folks, it is so important to me that this is not all about how, show me how to do the problem. Show me how to do the problem. Show me how to do the problem. Because you're just learning processes. You don't understand why things are. Once you understand the why, that's when you truly understand things, okay? Now, how are you going to keep it straight in your head? Well, here's how I keep it straight in my head. And you're going to laugh, and you're going to make fun, and I don't really care. Because I don't care. If a function is symmetric to the origin, it is what type of function? I know, you're shocked. You are amazed. I can see the amazement on your faces. You're welcome, y'all. I'm saving lives every single day, 3 times a day. I can tell you're excited. Calm down. Calm down, Cassie. Calm down. Now, this one is the one that that's kind of a cool, I mean, that was an easy connection to make, right? Odd origin. Oh. This one, when a function is symmetric to the y-axis, we say, or I say, y, x, y, z, right? But if I were from the north, then how would I say that letter? Say it again. I would say y. Do any of y'all say y? Y. Do you see that? If I were a Yankee, for real, not just then, Yankee, get it? Didn't mean for that to happen. But if I were from the north, then I would say y. Do you see the connection? Just put y. I don't know. You'll know it when you see it. You're going to go, oh yeah, y. I get it. A symmetric to the y-axis, even function. Origin odd. That one's easy. I don't care about the x-axis because it's nothing. It's nothing. Wake up, children. You act like you were up all night playing video games.
11.
Up all night long. Your bedtime's 9 o'clock. Don't even. Just kidding. Would that suck to have bedtime tonight? At how old? 16 and 17? There are people who do. They might be sitting next to you. Or standing in front of you. If I could be in the bed by 9 o'clock every night, I would be. All right, here we go. Yeah, get you right. That's a lot of stuff, isn't it? Does that make your head hurt? It does. It makes my eyeballs hurt. Let's do this. How to determine symmetry. Algebraically. There's got to be a shorter way to write all of that without copying that whole stinking slide. All right, we want to determine, what was the first one? Odd? Odd function equals symmetric to origin. How am I going to determine symmetry algebraically? Well, if I suspect that the function is symmetric with respect to the origin, then here's what I'm going to do. I'm going to substitute negative x for x and negative y for y. If I get the original equation, after substituting, does that make sense? Look at the way I have that written out. Does that make sense? Okay. Did I spell? I probably spelled that. I don't care. It's not a real word. Subbing. It's an abbreviated word. Then it's symmetric to the origin. It's got to be a shorter way to write all that mess on the last slide, so this is what we're trying. Okay? And the thing about this, folks, you have to test all three. You got to see, is it symmetric to the odd, or to the origin? Is it symmetric to the y-axis? Here we go. If it's an even function, which equals symmetric to the y-axis, origin has it all. Got to do everything to it. If it's symmetric to the y, in my head, I think I have to go opposite, opposite. Well, what's the opposite of y? What's the opposite of x? Negative x. So I'm going to substitute negative x for x. If I get original equation, then symmetric to the y-axis. And you'll see how this works here in just a second. If it's symmetric to the y-axis, what's the opposite of that? X. What's the opposite of that? Negative x. So I'm substituting negative x in. And then I have to determine it can be neither, which means it's symmetrical to the x-axis x-axis. What's the opposite of the variable x? What's the opposite of y? So I'm going to substitute negative y for y if I get the original equation. After substituting, then I'll say that it's symmetric to the x-axis. Okay? This is the how. These are clear instructions of what you need to do. This is how to algebraically determine the symmetry. You can't get home and go, I don't know what we're doing. Because the instructions are there and you notice, I ain't buying that. And if you don't email me, I sure ain't buying it. You better figure out a way to get in touch with me, okay? We ready? So how are we going to do all this with equations, right? Are we ready? Awesome. You guys are so out of control. You need to calm the heck down. Y'all are crazy. Not this. Not this. Look at this. Put that first one. that first equation. Y equals negative x squared plus 6. For whatever reason, I always try the y-axis first. For no reason, I just try, okay? So I will put symmetric to y-axis, okay? That is my clue because y. What's the opposite of y? Talk to me. What's the opposite of x? So what am I going to plug in? Negative x. All right, so here we go. Anywhere I see x, the negative has to come down. That's part of the equation. I'm plugging negative x in for x, and then I've got to simplify this. Folks, what is negative x times negative x? Positive x. I'm bringing down this negative symbol. It has to go. It's part of the equation. But this thing right here becomes positive x squared. Is that the original equation?
Yes.
Yes, it is. It is the original equation. So what's that mean? This function is symmetric to what? The y-axis. What kind of function is it if it's symmetric to the y-axis? Okay? It's an even function. Do we need to test them all? Yeah, we should. Okay? The next one, let's try, don't even pay attention to that. Let's go symmetric to the x-axis. I want to show you what's going to happen when it doesn't work out. What are you going to see when it doesn't work out? If it's symmetric to the x-axis, what's the opposite of x? What's the opposite of that? So I'm going to plug in negative y wherever I see a y. Do you get it? Okay, so here we go. Negative y, because we're still working on this equation, first one, is equal to negative x squared plus 6. I got to try to make it like the original. So I'm going to divide by what number? Negative 1. And what we do to one thing, we have to do to everything. Okay? I'm trying to make this equation look like my original. Okay? And the only way I can do that is by dividing by 1. Negative 1. Are you with me, yes or no?
Yes.
Okay. What's negative divided by negative? Positive. What's the negative divided by negative? Positive divided by negative. Is that the same equation I started with? Is it symmetric with respect to the x-axis? No. Now, I plugged in a negative y. I plugged in a negative x. What's the next one I have to try? Symmetric to the origin. Okay? I got to try both. Here we go. I'm plugging in negative y, and remember that negative sign goes down with the equation, negative x being substituted in for x plus 6. What's negative x squared? Positive x squared. Folks, look at that. Have we already seen that? It's the one we just did. What do I have to do now? Is it going to work out? No, it's not. But do I stop here and go, I ain't doing no more? No, you got to prove it. You got to prove it. So what am I going to do? Divide by negative 1. And we divide everything by negative 1. What is a negative divided by negative? Positive. Positive divided by negative is it the same? Heck no. So what kind of function is it? It's an even function. It is symmetric to the Isn't that fun? I mean, that is a barrel of monkeys right there. That is some fun stuff. We're going to continue going over symmetry tomorrow because you have to know how to find it algebraically. Okay? Here's what I want you to try. I want you, for your homework, to try to find the symmetry for example 2. Okay? Algebraically. Don't you dare touch that calculator. If you do, I'm going to break your fingers if I find out. I would, maybe, if you try to break my fingers. So I want you to try that symmetry on example 2. I also want you to do this for me. So example 2, which was, what was it? XY equals -6. Symmetric to what? You got to prove it. And then I want you to take your books and look at page 19 in your textbook. TB means textbook. I want you to do 9 through 12. That's just domain and range from a graph. Just a review of that. And then I want you to look at 20 and 23. And folks, that's finding the x and y intercepts algebraically. Okay? And then your symmetry is up here. I'm going to do this. Okay? Now, what's CWHW? Classwork homework, because you do have time left, for real. Even if it's just like 30 seconds. I know you want to pack up, and I know that's what you're going to do. That's cool. I know you're going to do that. Can you do all that for me? I mean, that's a lot, y'all. You know, I know it's a lot. So not a lot. Use your time wisely today.